Welcome back, students. So in this video we'll be doing the last 3 questions of exercise 1.2. So in this question we're actually asked to check whether 6 to the power n can end with the digit 0 for any natural number n. So when we talk about natural numbers, we talk about numbers like 1, 2, 3 and so on, okay? Clear? So we're asked to check if 6 to the power n can end with a digit 0. It should end, okay? It's not that it should just end. So in the sense, all the numbers that ends with 0 like 10, 20, 30, 40, yes, all these numbers end with 0, right? So we're actually asked to check if 6 to the power n can end with a 0. So solution 6 to the power n, you know that it can be written as, okay, it can also be written as 3 into 2 to the power n, right? Because 3 into 2 gives you 6 to the power n. And for any number to end with a 0, for any number to end with 0, okay, it needs the prime factorization of 2 into 5, right? Yes or not? Okay, every number, for example, you take, if I tell you to take the prime factorization of 10, you will take 2 into 5. If I tell you to take the prime factorization of 20, you'll take 2 into 5, right? But either ways, for every number, in the case of this, 2 into 2 into 5, and in the case of this, 2 into 2 into 2 into 2 into 5, right? It keeps on increasing in a sense, it keeps on increasing, but basically for every number that ends with a 0, you at least need 2 into 5. The minimum requirement is 2 into 5, yes? Okay? Clear? So for any number to end with 0, okay, for any number to end with a digit 0, it needs the prime factorization of 2 into 5. But hence 6 to the power n cannot end with 0, okay, cannot end with 0 because, okay, because 6 to the power n has prime factorization, it's just a repetition again, prime factorization of 3 into 2 to the power n, okay? Clear? So I hope you're getting it, right? For prime factorization, for a digit to end with 0, we need 2 into 5. But for 6 to the power n, you take no matter what, okay? In the sense, 6 to the power n could be any natural number. So you're taking 6 1, 6 twice, 6 thrice, 6 4 times, okay? So 6 times 1 is 6. 6 square is 36. And this would give you 216, I suppose. Okay? So you take any number, you're always going to get these numbers only, okay? So, and for this 1296, so for any values of 6 to the power n, you take 1 to keep on increasing the powers, you're going to get 636, 260. So it's not possible at all at any moment of time that you will end with a digit 0, right? Also, you focus on the prime factorization. For any digit to end with a prime factorization, for any number to end with a digit 0, you always need 2 into 5. Here, 6 to the power n, you get it by 3 into n, so simply not possible, okay? So this should be your answer, alright? The next question is this: we should explain why this is a composite number. So I hope you're clear with what a composite number. A composite number basically has factors other than 1 and itself, okay? Clear? So composite numbers are going to be 4, 6, 8, 9, 10, all this, right? And 3, 5, 7, 11, these are all prime numbers. 2, 3, 5, 7, 11. Please remember, 1 is not a prime number, neither is it a composite number, okay? 2, 3, 5, 7, 11 are prime numbers, right? And 4, 6, 8, 9, 10 are composite numbers because they can be written as, they are multiples of not just itself but also of other numbers, right? So in the case of 4, it is 1, okay, and itself, which is 4, but it can also be multiplied with 2. In the case of 6, it is a multiple of 1 itself, that is 6, 2 and 3 as well, okay? Same case for 8. It is a multiple of 1 itself, which is 8, then 2 and 4. Same goes with 9, clear? So we're asked to explain why this is not a composite number. So in this sense, when we talk about composite numbers can be factors. They consist of multiple factors, right? So you see, they consist of multiple factors. Are you able to see this, right? But when you talk about 2, if I tell you to write this as a prime factorization, you can only write it as 2 because 1 is not a prime factorization. You really cannot write 1, okay? So 2 is 2, 3 is 3, right? 7 is going to be 7 itself. 11 is also going to be 11 itself. So if you just pay attention to this, for prime numbers, the prime factorization of a prime number is itself, which is 3. For the case of 2, it's 2. For the case of 3, it's 3. But when we talk about composite numbers, it has, let's just say it has multiple factors. Okay, 3 into 2, 2 into 2 into 2, 3 into 3. Okay, therefore, we shall first begin with this. 7 into 11 into 13 plus 13. We'll explain why. Now, if you pay attention to this, focus on this, 13 is common to both. So if I take 13 out, I'll be left with 7 into 11. Okay, see, I've taken out 13 here. Okay, I've taken out 13, so I'm left with 7 into 11. In place of 13, you can always put 1, right? Because I've taken out 13. Plus, I've taken out 13, so 1 remains here. So 13 into 77 plus 1. So 13 into 78. Right? Now, if you just okay. So it's 13. If I tell you to expand this 78 into a prime factorization, you'll write this as 2 into 39. Now look at this. These are what? Multiple factors already, okay? Okay? Multiple factors. Remember what a composite number is? They can be written as factors like this. Prime number can just be written like this, okay? So obviously, because you're able to write it as a factor of something, which is 13 into 2 into 39, in fact, you can even further write this as 13 into 1, right? So you're able to write this as 13 into 3, okay? So this is going to be 2 into 3 into 13 square. So this clearly is a composite number because you're able to write it as a factor set. So hence, it is a composite number. It is a composite number, okay? You can just pause the video and write this down. I'll clear this screen off, clear? And then we'll work with the next question. So I hope you're clear with this, okay? The next we'll be working on is with this number, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So you just take, you take 5 common because 5 appears for all the rest. So 7 into 6. So since we have taken out 5, you're left with 1 into 4 into 3 into 2 into 1. Plus, you have taken out 5, right? So this is going to be 1. So 7 into 6 into 4 into 3. So this will be 5 into 1008 plus 1. So 5 into 1009. Alright? Okay, I hope you're clear with this. Now, since this is again a prime factorization of sort, okay? So this is 5 into something, right? So this cannot be a prime number because prime number is, when I tell you to take a factorization of a prime number, it's just going to be itself. 2 is going to be 2, 3 is going to be 3, 4 or 5 is going to be 5, right? But in the case of this, you see 2 factors, 5 into something. So clearly, this 7 into 5 into 4, this is a composite number, okay? This is a composite number. Because you can always, because it can be written as a factor of 2 prime numbers, okay? It can be written as a factor of multiple prime numbers, okay? Just write multiple prime numbers. Clear? Since you can write this it's a so many in the previous for this we got this as 2 into 3 into 13 square. So this is a factor of multiple prime numbers, right? 2, 3, 13 are all prime numbers, multiple prime numbers. So in the case of this, even 5 and 1009, not sure if 1097 or not, but anyways we get 2 factors, okay? So for the last question, this is given to us, okay? There is a circular path around a sports field. Sonia takes about 18 minutes to drive one round. Okay, so we're asked to find how many minutes will they meet again at the starting point. So Sonia takes 18 minutes to drive one round, while Ravi takes 12 minutes for the same. All right, so here they have a difference of 6 minutes, right? So we're asked, if suppose that they both start at the same point and at the same time, okay, and go in the same direction. Clear? They're not going to be driving at the same speed, but they're going to be starting at the same point and they're going to start at the same time. Okay, it's just start. Okay, start at the same point and the same time. Then how many minutes will they meet again at the starting point? Okay, therefore we have, so you can always write Ravi takes 18 minutes, or else in order, therefore minutes that they will take to meet again at the starting point. Okay, so we'll have to take the LCM of 18 and 12. Okay, clear? We have to take the least common multiple. Remember that they are not traveling at the same speed. Okay, they're just starting at the same point and at the same time. Okay, clear? So somebody could be driving at 60 km/h, somebody could be driving at 80 km/h. Okay, so they'll be taking different times. So we're going to be taking LCM. Okay, so when you take LCM, we try to understand the possible values. So this is going to be 2 into 2 into 3 square, right? Because 4 into 9, 12 is going to be 2 square into 3, right? So if I tell you to take the LCM of this, we're going to take the product of the okay, it's 2 into 3 square. We're going to take the product of the prime factorization with the highest degree. So in the case of this, there's both 2 available, but 2 square has the highest power. In the case of this, 3 and 3 square has the highest power. So this is going to be 4 into 9, which is 36. So they will take about 36 minutes. Okay, so they will take 36 minutes to meet again and from the same starting point. All right, so with this we shall end the video.